Okay, this is objective 2, solving the SSA triangle. Just to let you know that this triangle is called the ambiguous case. And the reason why it's called the ambiguous case is because honestly, without doing the math, we do not know if we have one triangle, two triangles, or no triangle. So we have to do further investigation to see what this is. And by the way, notice this is not an SAS triangle. So the angle is not sandwiched in between two given sides. You have two sides and an angle just by itself. So I wanted to point that out because if it's SAS, you just use law of cosines and you're done with it. But this one, just to help you remember, if you look at it backwards, it spells a bad word. So just saying, don't let that happen to you. So, SSA. All right, so let's check this out. There are actually two ways to solve side-side angle triangles. One, you can find the height by using side B times sine of angle A, or the other method is to use the law of sines. I like to use the law of sines because we already know how to use it from objective number 1. However, if you use the law of sines, you have to do further exploration to figure out if you have one triangle or two triangles. The nice thing about law of sines is if you do not have a triangle, you will know right away. So there's two ways. If you use the way that is in the notes, this is the way that I think my math lab does it, and the author, I think, takes both approach. But nonetheless, you have to find the height first. So you have to find the height of the triangle. Once again, take side B times sine of A. Then you compare it to various sides. So if side A is less than your height that you just found, you do not have a triangle. And the reason why is because that side A is not quite long enough to come down and hit the base of the triangle, which means that the height is longer than side A. That means we don't have a triangle. So you can have one right triangle, and that's when side A is equal to your height. If that happens, you get this beautiful right triangle, and it's pretty easy to solve. There are two other ways that you can look at. You have two triangles, and I'm going to go over this because this does make sense, because when we use law of sines, you're going to see that you're going to have two angles, an angle and its supplement. But if we look here, that is when that height is less than side A and side A is less than side B. So what happens is side A can either slide in or it can be pushed out. Okay, so those are your two possibilities. So that's why we have A and A prime, let's call it. And what happens is angle B has two possibilities. You know, let's call this first one just plain old B, and then it has B prime, okay? And I also want to point out through this diagram that both those angle B's, B and B prime, let's draw them up again, create a straight line. That is called a supplementary angle. Supplement means two angles sum to 180 degrees. And we're going to use this knowledge when we use the law of sines to figure out, once again, if we have one triangle or two triangles. Okay, and then finally, the last example, if you're using the height, you can find the height, but if A is bigger than or greater than or equal to B, then we only have one triangle. So you have your choice. If you want to use this method, I put it in the notes, use it. That's fine. If you want to use my method, I'm going to show you how to do it in 1 second. So what I've done here is I have written down the steps to see if we have one triangle, two triangles, or no triangles. So once again, you only have to do this with the SSA case. Otherwise, you just use the law of sines like you normally do. So the first thing you're going to do is you're going to use the law of sines because you're going to be given a side and the corresponding angle. So let's use, A as an example. So I'm given A and I'm given side A, okay? So I use the law of sines, I set up the ratio. I got to find the other angle because I'm going to be given another side. Let's just, for argument's sake, say that we're given, and I'm going to write this down. Let's say that we are given side A, side B, an angle B. Let's say that's what we were given here. And I'm going to fix this up because that B looks really bad. All right, so let's say we were given that just for argument's sake. So when we use law of sines, we find angle B. But if you're doing this and you get a domain error, that means that you do not have a triangle because angle B does not exist. Okay, so if you get domain error, you can tell right away, hey, we don't have a triangle, and you're done. However, if you get a value for angle B, then you have to figure out if you have one triangle or two triangles. How do you do that? You have to find the supplement to B. Now remember, I showed you that diagram that showed that angle either pushing in or pushing out. So to find B supplement, you have to take 180 minus the value of whatever you found for B in step number 1. Okay? So once again, you have to find B complement. Then the next step is you're going to have to check B complement to see if it works with a given angle. So how do you do that? To do that, you have two possibilities. First of all, you're going to have to add B complement to the given angle. In this case, remember A was given. So we have to add A plus B complement. And then we got to figure out, is it greater than 180 degrees or is it less than 180 degrees? And why 180? The reason why is because remember, the interior angles have to sum to 180 degrees for a triangle to be classified as a triangle. Okay? So if I find the given angle A plus B complement is greater than 180, then that doesn't make sense. That means that I have only one triangle, and I'm going to find all my values using just angle B. If, when I add A plus B complement is less than 180 degrees, that means you have two triangles. So you're going to have to find all the values with angle B that you found in step 1, and then you're going to have to find all the missing values with B complement. So you will have two sets of values because, remember, B and B complement are not the same angle, so it affects everything else. Okay, so I just want you to see that and see the steps. So let's go ahead and figure out two of these, and then we're going to have, I'm not going to lie to you, we're going to have part 3 to this video as well. So let's go ahead and do that. Okay, so here's our first example. Solve the triangle. Side A equals 3, side B equals 2, and angle A equals 40 degrees. Before you determine what you should do, you need to draw it out. So let's call this A, B, and C. Remember, A is 40 degrees, side A is 3, side B is 2, and side C is, I have no idea. Okay, so if I look at this, I notice that my given values is not side, angle, side. If that was the case, we'd have to know angle C, and we don't. So that since it's not SAS, and remember SASY means law of cosines, I have to use law of sines. Okay, and remember, I know that this is a bit ambiguous case. This is side, side, angle, so that means I have to explore. Okay, and I gave you the steps, so you're going to have to follow them. So let's go ahead and do step number 1. We got to find angle B. And the reason why we're finding angle B is because side B is known, whereas side C is not, so that doesn't help me. So what I'm going to do is I'm going to set up the ratio, sine of angle A, which is given, over side A, which is given, equals sine of angle B over B. So then I'm going to draw this out. So sine of 40 degrees over A equals 3. Sine of angle B I don't know, over side B I do know, which is 2. Okay, cross multiply because it is a proportion, which gives me 2 times sine of 40 degrees equals 3 times sine of B. So 2 sine of 40 degrees divided by 3 equals sine B. To get B by itself, I have to use inverse sine. So I'm going to find the sine inverse of 2 times sine of 40 degrees over 3. Okay, when you stick that into your calculator, I'm going to find out that B equals 25.4 degrees. Okay, So I know right at this point, because I didn't get a domain error, that I have at least one triangle. The question is, do I have one triangle or two triangles? So I have to explore. Okay, to do that, remember I told you we have to find the supplement of B. Okay, to find the supplement of B, remember you take 180 minus whatever B is. So 180 minus angle B, which we found to be 25.4, gives me a value of 154.6. Now, the next step I told you to do was to add your supplement of angle B plus the given angle, which in this case is A. So 154.6 plus angle A, which is 40, gives me 194.6. Okay, this value is greater than 180 degrees, so I know I do not have a triangle. Because if it's greater than 180, that doesn't make sense. So, do we have two triangles? The answer is no. So there's not a second triangle. So if there's not a second triangle, I don't do anything with B complement, okay? So I can kind of ignore it. I'm just going to put a line through this really quick, just so you know I'm ignoring that work because I don't need it anymore. Okay, so I know I have one triangle, so what I have to do is I have to go through and find the rest of the values for the given triangle. Okay? All right, I'm going to do that on the next page. I'm just going to redraw the triangle for you, and we're going to solve for side C, angle C, and that's it. Okay, since we concluded we just have angle B and we don't have a supplement to it that works, that makes a triangle, I'm going to go ahead and figure out the rest of it. So we're going to go ahead and find angle C next. Okay, so remember I have 180 degrees minus 40 degrees, that's angle A, minus angle B, which is now 25.4 degrees. And when I subtract those, I get 114.6 degrees. Okay, so now I have angle C, I have angle B, and the only thing that I am missing now is side C. Okay, so to figure out side C, once again, use the law signs. So I'm going to do sine of angle A, because that was given, over side A, which we know. Sine of angle C, which we just found, over side C. So let's go ahead and do that. We get sine of 40 degrees over 3 equals sine of 114.6 over side C. So I get C times sine of 40 degrees equals 3 times sine of 114.6 degrees. Solving for C, I get 3 times sine of 114.6 degrees over sine of 40 degrees. So go ahead and plug it into your calculator. Make sure you're in degrees. And when you do that, you get side C equals 4.24. Okay? All right, so we just figured out this triangle. Hooray. Let's go see another example. Solve the triangle side A equals 6, side B equals 8, and angle A equals 35 degrees. So we're going to go ahead and draw this out. A, B, C. Angle A is 35 degrees. Side A is given as 6. Side B is given as 8. And side C we don't know. So once again, we have a side, and an angle. However, we don't have SAS. Remember, if we have SAS, it's sassy, snake. That is law of cosine. So I can conclude that I have to use the law of sines. And once again, because this is side, angle, we have to do further exploration to figure out if we have one triangle, two triangles, or no triangle. Okay, so since we figured this stuff out, we can go ahead and move on. I'm going to go ahead after angle B. So I do sine of angle A over A equals sine of angle B over B. Sine of angle A. Angle A is 35 degrees over side A, which is 6, equals sine of angle B, which is the unknown, over side B, which is 8. Okay, so I'm just double checking that really quick, and we're good. All right, so the next step that I'm going to do here is I am going to use cross multiplication, and I get 8 times sine of 35 degrees equals 6 times sine of angle B. Solving for B, I get inverse sine of 8 sine of 35 degrees over 6 sine. Oh, sorry, I shouldn't put the sine there. I don't know what I was thinking. Just put over 6. That's why I stopped and like, that sounds weird. Okay, so I have inverse sine of 8 sine of 35 degrees over 6 equals angle B. Okay, when you jam that into your calculator, you get angle B is 49.9 degrees. Okay? Remember, if I get an angle and I don't get a domain error, I have to check to see if I have one triangle or two triangles. So let's check. So remember I told you you have to find the supplement of B. Okay, so to find that, I take 180 degrees minus B that I just found, which was 49.9 degrees. And when I take 180 minus 49.9 degrees, I get 130.1 degrees. Okay, the next thing I have to do is see if it makes a triangle. So I'm going to have to add A plus B supplement. So angle A is 35 degrees plus 130.1. And when I add those together, I get 165.1 degrees. I notice that 165.1 degrees is less than 180 degrees, which means I have two triangles. Okay, I have two triangles here. And once again, I know that because when I added angle A to the supplement of B, that was less than 180 degrees, okay? So what that means is I have to find all missing values for a triangle with B. So I'm going to have to find angle C and side C, and then I'm also have to find all missing values for a triangle with B complement. So I'm going to have to find C complement and side C complement. Okay, so we have some work to do. So let's go ahead and do that, and the rest of it is actually not that bad. Okay, so the first triangle we're going to find is where B equals 49.4 degrees. Side A was given, remember it was 40 degrees. Side A was given as 6 and side B was given as 8. So I need to find angle C. To do that, I'm going to take 180 minus angle B minus angle A, and that should do the trick. So 180 minus angle B, which is 49.4 degrees, minus angle A, which is 40 degrees. And when I do that, I get C equaling 95.1 degrees. Okay, so I found side C, so check. And now I have to find side C. So I found angle C. All right, so let's do this. Law of sines. Sine of angle A over A equals sine of angle C over C. So sine of angle A, remember, was 40 degrees over side A, which is 6. And that equals sine of angle C, which is 95.1 degrees, over side C. So crisscross applesauce, I get C times sine of 40 degrees equals 6 times sine of 95.1 degrees. C equals 6 of sine of 95.1 degrees divided by sine of 40 degrees. So go ahead and put that in your calculator and you'll find that side C is equal to 10.42. Okay, so I finished the one side. Now I have to go and get the other side. So I'm doing this triangle based off of B complement. Remember, B complement was 130 degrees, 0.1. Remember, angle A doesn't change. It was given as 40 degrees. So is side A, which was given, which is 6, and side B, which is given, which is 8. So I had to find C complement, or C supplement, excuse me. In logic, we call that a complement sign, so I keep on screwing that up. But the supplement of C. So what I'm going to do is I'm going to take 180 degrees minus angle A minus B complement. So 180 degrees minus the given angle A, which is 40 degrees, minus B complement, which is 130.1 degrees. And when I do the math, I find out that C supplement is 14.9 degrees. All right, now I have to find side C complement. C supplement, geez. All right, so once again, law signs. Sine of angle A over A equals sine of angle C complement over side C complement. So sine of angle A is 35 degrees over 6, which equals sine of 14.9 degrees. Sorry about that. We have some room over C. If I cross multiply, I get C times sine of 45. I lied to you. C of sine of 35 degrees equals 6 times sine of 14.9 degrees. And when you do the math, you're going to find out that C, and I should call this C supplement, is equal to 2.69. So that's its side length. Okay? So once again, notice we have two triangles, and when you have two triangles, you have to do twice as much work. Okay, I'm going to stop here because this is getting really long, and there is going to be a part 3. Okay.